session where I'm going to cover the fundamentals. But again, there is so much to learn. Today, I'm going to build a foundation for you. So you can think of it as a kind of an entry point into the world of version control. But by the end of this session, you will understand the basics. You will see why you have to master Git, which is very crucial for your development, for your career. And for those who want to go deeper into learning GitHub, I'll be sharing the details about our comprehensive 4-hour workshop where I'm going to tackle the advanced concepts and the real world scenarios. And moving on to the second slide. So just a quick question before we dive in. So I want to understand where everyone is starting from. So there are no wrong answers here. So whether you are a complete beginner or you have some exposure in GitHub. So this will help me to tailor my discussion. So just a quick question to start with. So have you ever used Git before?
No.
No. Okay. Any other answers?
Yes, I have used it, but basic level, like not for the much. Just to like keep track of our performance scripts or something like that in the Bitbucket or something. So for that reason, I've used it.
Mhm. Any other answers, please? I'm not going to judge you. Anyways, everyone is in the same place. Everyone is learning, so nothing wrong here. And do you know what GitHub is? So GitHub. So do you know what GitHub is? Have you ever have an account with GitHub?
I mean, yeah, GitHub is the repository where we will store our code base from local to the remote.
Yep. Thank you. Thanks, Anil. So have you ever worked in a team coding project? In a team level?
Yeah, I'm working currently.
Okay. Thank you. And have you ever heard of terms like commit or branch?
Yes.
Okay, thank you. So this gives me a great sense of the room. So I can see we have a mix of people. So don't worry if these terms are new to you, but by the end of the session, they will all make sense for you. So for those who have used a Git little, you will solidify your understanding. And for complete beginners, I welcome you all. So you are in the right place at the right time. And now moving on to the next part. What is version control? So let's start with the very fundamental questions. So what is version control? So like think of it like the video game where we save our points for your code. So when you're playing a game and you save your progress. So maybe you're right about to fight your enemy. So you save right before. So if you die in that particular point of time, so you can reload from the save point, which means version control does exactly that for your code. You save the snapshots of your work, and if something breaks, you can immediately go back. You don't need to worry about like starting from the scratch. So that is what the version control does for us. So you'll have the snapshots of your work. So just remember this word, the snapshot, because that's going to help you throughout your Git. Snapshots is where you're going to save your work, and if something goes wrong or if something breaks, you can very well go back and take it from there. And the next one is it enables multiple developers or testers or anyone who works together seamlessly. So imagine you have 5 people trying to edit the same Word document at the same time. So you're passing a USB drive around your team. So it is again a kind of a chaos situation, right? Because you have 5 people who are trying to access the same file at the same time, and you're passing a USB drive to make the changes. But version control solves that problem because multiple developers can work on the same project simultaneously without stepping on each other's toes. And that's what we're going to see how it's going to happen. And then providing the complete history, that is you can travel back in time. So every changes you make is recorded. It will show who made it, what they made it, and why they made it. So you can literally go back to any point in your project's history. If you made a change like 3 weeks ago that broke something, you can see what exactly has changed and what was changed and who did made the change. So you cannot escape from your team. And then the next thing is the essential skills for modern software development. So I'm not exaggerating, but when I say that every professional development job expects you to know the version control, it's not at all an optional anymore. It's fundamental now. And the next thing, Git is the industry standard. Yes, over 95% of developers, testers, DevOps engineers, cloud engineers, no matter what, whoever you point out in the IT field, they use Git, and it's becoming the de facto standard. So usually, like 5-10 years back, people used to ask us, like, do you know MS Office to work, or do you know the basics of Windows? So something like that. Now Windows, the Git is getting the de facto standard. So learning Git is like learning to type for a writer. So it's just expected. And any questions so far? Any questions or any doubts or anything? Okay, I take it as a no. Moving on to the next one, the fun fact. So a quick fun fact before we move on to the serious concepts or topics. So Git was created by Linus Torvalds, the same guy who has created the Linux, the same guy who created the Linux for us, the Linux operating system. And he built in just 2 weeks. Yes, he took just 2 weeks. So he basically locked himself in a room and he created what would have become the most common, most popular version control system in the world, in talking terms of productivity. And then Git, yes, Git is a British slang for unpleasant person. So it's basically he calling someone an idiot or annoying person. And Linus named it after himself as a joke. So he had a sense of humor about himself. So in his own words, I'm an egoistic person, so I name all my projects after myself. So in fact, that's why we got Linux, and now we have got Git after that. And today, over 100 million developers use Git worldwide. And from that 2-week project to powering virtually every software company on earth. So any open source that has been built is being built using GitHub. So in fact, it has different versions, like they have given public, private, internal, enterprise versions of Git. And once you start working on it, you will know better than this. So back to learning, but it's nice to know the tool we have used, that we are using, has some interesting stories behind it. And moving on to the Git versus GitHub, like we'll spot the difference between these. So this is probably the most common confusion for beginners. So let's clear it right up now. So Git and GitHub are not the same thing. I in fact had the same doubt when someone was asking about, do you know GitHub? I was having Git in my mind, and I told them yes, I know. And then when they asked me to work on GitHub, I was like confused. This is not GitHub, but the same confusion, yes, will happen for the beginner. So that's the reason I'm trying to break it at the very starting moment. So Git is something. Let me quickly show you with a command prompt. I'll just show you what some basic commands. So if I type Git, so this is the command, which means anything that is related to Git is in my personal mission, right? And when it comes to GitHub, which is something that is in the internet, that is somewhere in a different location. So Git is in my location, in my local machine, and GitHub is in a different location. So I'll explain you in detail now. So the Git, let me just move it a moment. Yeah. So Git, which is the version control software on your computer or on everybody's computer. So Git is a program where we install on our laptop. So it runs locally, as I told you, as I've showed in my command prompt, and I can use Git without even connecting to the internet. Yes, so any change that I can do in my command prompt, I don't need an internet. I can do whatever changes I want to do. I can do it in my local machine. So that's the actual version control system, right? And now talking about this GitHub that you see here. So the GitHub part, the GitHub part that you see here is the cloud platform for hosting the Git repository. So GitHub, again, that as you see here, is a website. Yes, so think of it as like kind of a social network, like something like a Facebook or Instagram for coding, right? In Facebook, what we normally do is like we post videos, we post photos, right? The same way to post your code, you're using this social network. So when I say social network, yes, so lots of people were there, like tons of people, like millions of people were there. So it's a kind of a social network for code. And if you want to collaborate with any of the project, yes, you can very well do it. You can do like lots of magic. I mean, again, some of say for example, if you want to participate in Kubernetes development, yes, you can very well do that. So for example, if I go to Kubernetes repository, this is the official Kubernetes project, and you can even go to the README file and you can see them here. And yeah, you can even participate as one of the contributor to it if you are interested to do it. So again, as I told you, this is a social network for coding, and it's owned by Microsoft. So previously it was with a different, I think it was with Linux or someone, but I think later it was bought by Microsoft, and it provides a place to store your Git repositories online. And Git, as I told you, the one that I showed you in the command prompt, it works offline in my machine without any internet, where I can create, where I can commit, I can create branches, I can view the history all on my local machine with Git. But with GitHub is for when you want to share or when you want to collaborate or back up your code online. See, for example, for making any changes to your photos or in your videos in your phone, you don't need an internet, right? You can edit your photos, you can edit your video, right? But at the same time, if you want to upload your photos or if you want to upload your videos in Instagram or in Facebook, you need to be online, right? So that's the same difference. And now GitHub adds um, extras. So when I say extras, um, Git built a whole ecosystem around Git. Yes, you get collaboration tools, you get project management features, code review systems, the things which Git itself does not provide, because after Windows has acquired it, there are a lot of changes. So there are alternatives that exist for GitHub. Yes, we do have GitLab, we do have Bitbucket. Sorry, we do have Bitbucket, we did have Azure DevOps. So GitHub is the most popular, but it's not the only option. Yes, GitLab is open source and popular in some companies, and Bitbucket is also been integrated well with Atlassian tools. When I say Atlassian tools like Jira or Confluence. And Azure DevOps is Microsoft's other offering for enterprise. So if you're someone who works as a DevOps engineer, you must know about the uh, GitHub, the Azure DevOps one. So remember, Git is the tool, right? Uh, what is it? The popular Git that I showed you in the command prompt. It's a tool, but GitHub is a service that hosts the Git repository. So you can use Git without GitHub, but you cannot use GitHub without Git. So I believe it makes sense. So you can use Git. That's a command prompt without using the internet one, the uh, website one. But you cannot use the GitHub, because if you want to make any changes, you want to upload any changes, so for that you need the Git, right? Or the Git knowledge. So now the next one, so some quick question time. The first thing is, if Git is like Microsoft Word, then GitHub is like Google Docs. Yes. So let me explain. So when I say Microsoft Word, so the one that you have installed in your machine, so GitHub is like Google Docs or like Microsoft Docs. Even Microsoft Docs is also there. So let me explain. So Git is like local saving. So you can locally save your documents, right? But when you write a document in Microsoft Word and you hit save, that file lives on your computer. But similarly, Git saves your code history on your local machine. On the other hand, the GitHub is like cloud collaboration. So Google Docs lets you save your document to the cloud and share it with others who can view and who can edit. But GitHub does the same for your code, but it's in the cloud. It is shareable and it is collaborative. So when you're doing in Google Clouds, the Google Cloud documents, it's not in your machine, but it is in the cloud. So the same way, it's difference between the Git and GitHub. And I believe this analogy makes sense. And any questions so far in terms of the difference between the Git and GitHub?
No.
Okay,
No.
thank you. And moving on to the core concept. So we're going to talk about the repositories. So now it's the core concept in terms of the GitHub. So the first thing is the repository. So your project folder is going to be tracked by the Git. So think of a repository as a project. So okay, so if you're building a website, that entire website folder can be a repository. So if you're building a mobile application, for example, so that app folder is a repository. It's just a folder, but a special one that Git is watching. So that's what we call it as a repository, which is a kind of a folder setup, right? So it contains all your files, all your folders, and complete version history. So it's not just your current code files. It's a repository which contains every version of every file, not just one file. Whatever files you have, so it will store its version. It will store every code and everything is stored. And as I told you in the very first slider, it's about the snapshot. So it has a snapshot of your saved files. So it's like having the infinite save as copies, but it is managed independently. So say, for example, if you remember a few years back, I remember personally, when I create a file, I create like final, and then I create final 1, and then final 2, final 3. I keep on creating new files, right? But when it comes here, you can actually save the file in just one name as final, but every changes that you make will create on top of the same file. So that is exactly the difference. And that is why actually it saves a lot of time. It saves a lot of effort. In my personal experience, I would say this example. And then the local repository, which lives on your machine. So this is the copy on your laptop. So you work with your local repository most of the time. Yes. So anytime that we want to make changes, yes, we are going to work on our machine. And the remote repository is something which lives on GitHub. So this is the copy in the cloud. So whatever you have that copy in the cloud on GitHub service. So it's going to be your backup and your collaboration hub. And then the repositories can be cloned, they can be forked, they can be synchronized. So you can make copies. So when I say copies, if you want to copy an entire repository, yes, you can clone it. And if you want to create your own version, you can fork it and you can keep them in synchronization. And we'll talk about more about these actions in a moment, because I personally have asked these questions in the interviews, like what is cloning, what is forking, because they both look same, but there is quite a difference. I'll tell you when do we clone and when do we fork. And everything in Git revolves around repositories. Yes, so you clone, you fork, and you pull, you push. So this is what happens in terms of the repositories, and they are the containers for your projects. The basic Git workflow. So talking about the core process. So now I'm going to show you the fundamental workflow that you will use every single day. Maybe a developer or a DevOps engineer or anyone who is in the field. So these 5 steps are the foundation for everything. So starting from initializing or cloning a repository. So you start a project in any of these 2 ways. So one is the initialization, where you create a brand new repository from scratch on your computer. And then you clone, which means you're going to copy an existing repository from your GitHub to your computer, right? So there are 2 things. One is the git init part and then the git clone. These are the 2 commands that we use. So think of cloning like you're downloading a project, but it brings the entire history with it. So when I say entire history, starting from the scratch, starting from the very first commit, every commit, every snapshot will be downloaded to your machine, right? So when you type git log on one line, you can get to see all the history of it. And then making changes to your file. So this is just normal development work. So you write your code, you create new files, you delete your old ones, you edit your existing files. So whatever your project needs, Git is just watching in the background. So it always sits in the background. It just watches whatever we do. And that's what we make all the changes. And then the staging of changes, right? So this is very unique to Git, because staging is like putting your items in a shopping cart before you check out. So you go to shop, Walmart or Tesco or whatever the shop is, you put every item in your shopping cart, you are pulling it to the checkout counter. So you tell Git, these are the changes I wanted to save or I wanted to bill, and you might have changed 10 files, but you only want to save 3 of them. So staging will let you choose what changes you want to do. So it's like, again, as I told you, until you bill it, it won't be your code or it won't be in the staging environment, right? So you have to be there are like stages. There are initialization stages, staging part, and then the committing part. And next comes the critical part, that's the committing changes. So committing is your save point. So you're telling Git, take a snapshot of all the staged changes right now, because each commit is like taking a photograph of your project, right? So you also write a message explaining what changed and why. Say for example, if you are like walking 10 steps from one place to another place, right? So if you're taking photograph for each of your step, it's like you're walking from one place to another, but at each point of time you're moving one step ahead, right? So that is what exactly is happening here. So you're gonna take a picture of your each step in your project. So each commit that you make is like taking a photograph of your project. Okay, but again, when you keep each step, right, when you do each commit, you have to actually write a message as well, like what you changed at this point of commit. Say for example, I personally I do, like for example, if I update a code in a Terraform file or in a YAML file, I used to add that. I made this, not like a very big story, but a kind of a one-liner, that this particular change. Because next time when I wanted to understand what changes I made, I can easily understand through the commit message, and that's what we use the commit message for. And okay, once you commit your changes, you're gonna push your changes to the remote. Okay, so you're going to share it with your team. So once you're committed locally, you will push those commits to the remote repository on the GitHub. That is the remote, the social networking for the code. So now your teammates can see your changes and your work is backed up in the cloud. So that's what happens with starting from the Git and it ends with the GitHub. So these 5 steps, that is the initialization or cloning, editing, staging commits, pushing your code, where you will repeat this cycle hundreds of times. So it becomes the second nature for you. Any doubts in terms of the basic Git workflow?
No.
No? Okay, thank you. Let's move on to the next one, understanding the commits. So let's zoom in on commits because they are absolutely central to Git. So talking about commit, as I told you, it's the reason why I'm dedicating a particular slide of a commit is you need to understand it, because sometimes when you're beginner and you're learning, or even at the experience level, or sometimes we used to get confused in terms of the commit. So that's the reason I'm again reiterating on this point, because commit is a snapshot of your project as at a specific moment. So imagine, as I told you, you're taking a project of your entire project, and that's a commit, because it captures the exact state of every file, right? Not just one or two files, as I told you, every file in your repo at that point in time. And each commit has a unique ID, which we call it as hash ID, like a fingerprint. So every person has a fingerprint, which is unique, right? So the same way, all these hash IDs are also unique. So Git generates a long string of numbers and letters for each commit. I can even show that to you in one of the, yeah. So if I go back to my repo, sorry, so if I go to my commits, yeah, so if you see here, view commit details. So this is the commit ID. So that is the one that you see here. So this is what will get generated. So again, as I told you, no two commits. So if you see here, it starts with F and then it starts with D, F2 again, 1666. Just imagine in the whole world, in the entire world, no two commits in the entire world have the same hash ID, and that's what it has been designed with. So that's how it keeps that's how Git actually keeps track of every single thing, right? And then moving on to the next one. So commit includes messages describing what changed. So if I show you, so this is what happened. So this is my message. So if I go here and if I go to this commit again, so this is the message. I've added a person here. I have merged a pull request. I have updated README. This is my message. So for each commit, I should have a message. If not, I cannot commit that. So I should have a message for all my commit messages. So I can write a brief description. So brief is actually small. So fixed login bug, and like you see here, update README, update health check, create health check.email. So something like this, I can create a message. Again, as I told you, this message helps you and your team to understand what has happened at that particular point of commit. And then you're gonna build a complete timeline. So as you can see here, the complete timeline, right? So starting from, if you see here, like starting from April 12th, so you can see the entire timeline of your project, like what has happened since beginning till the end, like whatever until the last point. So the string, I mean, like that you see here, the commits over weeks, over months, years, and you have a complete story of how your project have developed. So if you see here, I'm showing all the time. I think there are a few more commits. Yeah. So if you see, the very first date could be even further. But every single commit will be there. You will have the entire history of your work. And it's always good. Like if you have any bad messages like fixed stuff or changes are very useless. So always keep good messages like fixed email validation to accept plus sign address. So that's a kind of a simple example, I would say. So think of commit like a building block of your project history, because if you see, this was my initial commit. I added myself as a user, and then I did my first commit. I keep on adding users, and then there was a commit by Srini. I added another user, and this so it actually keeps on building. It's the same way you're building your application, right? And now let's move on to the interesting part, the commit message style. So speaking of commit messages, I'm going to do a quick poll because this is quite important. So I'm having the answers here. So which one do you think is better, right? The option A or option B in terms of commit?
Option B.
Option B. Okay. Thank you. Yep. So option B is a way better, and I'll tell you why. Because imagine you're coming back to this project in 6 months, so you see fixed stuff like a commit message, like fixed stuff. So you have no idea what you fixed. But just imagine if you have like fixed login button not responding on mobile, so immediately you know what that commit was about. You don't need to even, in fact, go inside the code, and you don't have to even see the changes as well, right? So your team will actually thank you for that. So when your colleague is like tracking down a bug or looking, because we are not always going to be the same project, and we keep on changing, and someone else will come, and when they watch it, they should understand what exactly has happened, right? So always keep like go through your commit history and understand like what has happened, and keep always descriptive messages, and that will actually save lots of hours and effort for everyone of your dedicated detective work. So talking about some real world tip, many companies, they enforce commit message standards. Yes, there is again a page. I will like I'll share you that. So if you go to the GitHub Docs, there is exactly a page where they will give you the exact format to enforce the commit message standard. Some useful formats like actually there are like formats. For example, like fix login button, which is not responding on mobile, and feature. And in fact, there are like these are the messages like fix, feature, docs. Like I've updated API documentation, something like that. So these commit messages are a sign of a professional engineer, a tester, or developer. So it seems very small, but actually it makes a huge difference to you and your team. And talking about the next one, the branches. So same way as in tree, yes, the branches are like separate branches, the sticks thing, but there is a difference here. So now this is one of the GitHub's most powerful feature, because on a overview, I'll tell you. So if you have like 10 people in your team, every person in your team can work in the same code, but in a different branches. So this is what Git really shines as for us. So a branch is an independent timeline for your code. So imagine your project is a tree trunk growing upward, and at some point you might want to try something experimental. You want to add a login button, or you want to add a submit button, or you want to add some emojis or something like that. So you create a branch that splits off from the main branch. Okay, so that branch grows independently from the main trunk. You can make whatever changes you want. That's not going to disturb your main until you merge it with your main. Okay. And then the main or master branch, whatever you call it as. So your production ready code. So your main is always your production code. You're not gonna make any changes directly there. So the trunk of your tree, so that's the main branch. So trunk, when I say the trunk of the tree, that's the main branch. So it's typically what's running on your live website, right? So the live website, whatever we see in real time, so they all run on the main branch, okay? Or what the customers is actually using. So it should always be stable and working. We should not, at any point of time, we should never ever touch the main branch. And then the creation of branches for new features or experiments. As I told you, if I want to make any changes to the main branch, I must not touch it directly in the main, but instead I can create a branch, I can play there, I can do whatever I want. So let's say you want to add a new user authentication system instead of working directly on main. As I told you, it's very, very risky. Never ever try to do the main, try to touch the main. You create a new branch called feature user authentication, or feature adding a login button, or feature adding a submit button. Now you can work on that feature independently. You can even build a stub. You can test that in your local branch, okay, or in the feature branch. And then you can work safely without breaking the main code base. Yes, this is very important, and this is very huge. You can try any crazy experimental ideas on your branch, and if they don't work, you can just delete the branch. You can come back to the main any point of time. So the main branch is completely unaffected. Your teammates will continue working normally on their branches. Yeah, so same way like you, there'll be other crazy people in your team, so they will be keep on making their changes in their branches. They can do whatever they want, but never ever make any changes in the main branch directly, and that's very unsafe. And then the merge branches back when the work is complete. Yes, once your work is completed, and once it's not just merge just directly, it has to be reviewed, it has to be like signed off by a peer or someone in the team. So once your feature is done and tested, and your merge, you can merge it back into the main branch. So it's like the tree branch growing into the trunk, but bringing all your changes with it, okay? So branches actually enable parallel development. That's the critical point here. So if multiple people are on the team, they can all do the parallel development at the same point of time. 5 developers, I mean, even more, can actually work on different features simultaneously. Like one can fix on feature, one can work on a fix, one can work on a document, one can work on something else, like whatever he wants to do. The flow, I mean, like, sorry, I missed something. Okay. After they make all the changes, they can then merge their completed work back into the main at a time, one at a time, not everything at a time, one at a time, so that they get reflected to the main slowly, and then they can check the changes. So this is how the modern software system, the teams are working. So in our full workshop that I was telling you about, I'll show you the branching strategies like Git flow and GitHub flow that large companies use. So these strategies that I showed you define when to create a branch, how to name them, and when to merge them. Okay. So now I think it's turning quite complex. So now, in terms of the branch naming, so quick fun thing here, because developers can be pretty creative and funny with the branch names. So some of the common professional names are like feature, new login, bug fix, header crash. So in professional settings, you will see structured names like this. They're very descriptive and they follow common conventions. And then the funny names which developers uses like fix, please work, or feature, why did I do this kind of. So when developers are frustrated or working late at night, yeah, people, I used to see a lot of change features and I mean like branches like this, but the branches name gets entertaining. And some of the real examples for actual projects, so it should be something like this. So feature, add more awesome. So this was a real branch that someone found in the production code again. And then the hard fix, everything is fine, I'm fine. So this one tells the story that you can feel the panic and the pain behind the person. And then in a professional team, stick to conventions. Yes, if you have some senior persons in your team, they will be very strict about that. I personally felt that heat. So while these can be funny, but in a real work environment, follow your team's naming convention. So usually use something like the type, the description. So where type, when I say type is the feature or fix or bug or whatever it is. So some companies enforce this with automation. Yes, so we do have that setup as well. So if you miss any of these keywords like fix or feature, you cannot create the branch. I mean, you cannot pull that request. So you have to change the branch name before you even create the pull request. So in your personal projects, you can name them whatever makes you happy. But once you have branch, once in your team setup, please follow their conventions. Okay. And then the next part, so we saw about commit, and then we saw about branches, and now it's about the pull request. So collaborating with the pull request. So now let's talk about it. How teams actually collaborate using the Git and GitHub. So this is where GitHub really adds value beyond just Git. Okay, so pull request is something like, hey team, you're telling your team that, hey, please review my changes. So a pull request I'm talking about is essentially you're raising your hand in your team and saying, I have completed my work on this branch. Can someone review it before we merge it to main? Okay, so it's called a pull request. So you're pulling your, sorry, actually, it's something like it I initially felt that confusion. Okay, so when you say pull request, you are not actually pulling something. Actually, you're pushing something. But the pull request is something from the GitHub's perspective. Okay, because GitHub is pulling your code from your local machine to its repo. Okay, so that's quite confusing. In fact, I had that personal confusion because when I say pull request, but I'm actually pushing my code, right? But that's kind of confusion because it's called a pull request because you are requesting that the main branch will pull in your changes. Okay, so this is in terms of the main branch. It's not from your branch. The perspective is from the main branch because it's called a pull request. Again, it's because you are requesting that the main branch should pull your changes to it. Okay, so that's why we calling it as pull request. And now the next thing is the team members who review your code before merging. So once you create a PR, once you create a pull request, your teammates will get notified. So they can look at every line of code that we changed. So they can exactly see what's different. I can even show you that one quickly. So for example, this README file, right? So if I go to my pull request, and if I like pick up one of my pull request, and if I go to files changed, I can exactly see what has changed, right? So if you see here, I'll just maximize it. Okay. So here, if you see, I can see exactly what has been changed, right? So if I go to my Kubernetes file, I can see what has changed, right? So exactly this is what happens. Okay. And then your team members, again, as I'm telling you, so once you create the PR, your team members get notified, so they can look at every line of your code that we changed. It's in this case I have added the entire code, but yeah, in some cases there will be like few lines in between the code, so they can exactly see what is different actually. And then you can discuss the changes. Okay, you can discuss the changes, and you can suggest improvements. You can approve or you can reject. So this is the collaboration magic. Yes, your colleague will have a comment that, hey, you have considered this edge case, or this function could be optimized, or just make changes in the code, it doesn't look right. So you have a conversation right there in this PR. So they'll give you the commit messages, they'll give you comment as well, and you have to resolve it before you even send it back to them. And then the next point, which is you're going to ensure the code quality and the knowledge sharing. So code review catches the bugs before they reach the production. It also means multiple people understand each part of the code base. So if you're on vacation, someone else will know what you built. And then the next part, which is the central to modern collaborative development. So I cannot overstate this because pull requests are how the software teams work today. Whether you are at Google, a startup, or even an open source project, PRs are the standard workflow. Because again, I'll tell you in the full workshop, we'll deep dive into how to create effective PRs, how to review the code professionally, how to handle feedback and request changes, and the best practices for PR descriptions and titles. Okay. So again, pull requests turn coding from a solo activity into a team sport, right? So any questions so far?
No.
Okay. Yep. Thank you. Right. Moving on to the next part, the cloning and forking. So getting on coding onto your machine. So let's talk about how you get code from GitHub on your computer, because there are different ways depending on the situation. As I told you, you can clone. So you can create a local copy of a remote repository. So cloning is a very straightforward. So you're copying a repository from your GitHub to your computer. You can use the command like git clone, and then you can give the URL. And at the next moment, you have the entire project on your machine, including all the history, right? And talking about the fork, yes, you're going to create your own copy of someone else's repository. Okay, so forking is different because when you fork a repository on GitHub, you are creating your own copy of that repository under your GitHub account. Okay, so now it's yours to experiment with. So that's the difference between the cloning and forking. Okay, because cloning is for team project you have access to. That's the difference. That's the key difference between cloning and forking. Yes. So cloning is for team projects that you have access to, because if you're working on your company's project or a team project where you have permissions, you clone it directly, you will be pushing changes back to the same repository. But forking is for contributing to external projects. Yeah. So let's say you find a cool open source project on GitHub that you want to improve. So you don't have permission to push directly to their repository. So what you'll do is you'll fork it. Okay. Until otherwise they'll give you in the settings they'll give you some collaboration. Like I can show you that part here. So if you go to the settings, where's my settings? So we go to the settings. Until otherwise they add you here. Sorry, just a moment. Yeah. So until you're part of the team, right? So if you go to the direct access, or until they add you here, until you get access to it, you are not a member of the team. So you are supposed to, you cannot clone, right? Until you have access to it, you cannot clone. You only have option to fork. Okay. And that's the difference between the cloning and forking. So you make changes in your fork, then you can create a pull request asking them to pull your changes into the original project. But what happens is both enable the distributed collaboration. Yes, so this is what makes Git distributed, because everyone has a complete copy of the repository. Okay, so there is no single point of failure. Even if the GitHub goes down, every developer still has the full history on their machine, right? So as I told you, the Git part, yeah, so they can have the full history on their machine. So think of cloning as joining a team, and forking as starting your own version of someone else's project. Okay, so any confusion in terms of cloning and forking? So now you know when to use cloning and when to use forking, right?
So wasn't just one clarity
Mhm.
here. Like
Yeah,
for the cloning, we can do any for public repositories, we can do the cloning. But for forking, like we need to get the permission from the like who owns the repository, right? So until then we cannot do that fork. Is that my
No,
understanding?
cloning is something where you have access to. Say, for example, let me show you this one. Is this okay? So if I go to these are my projects. Okay, if I go to any of these repositories, I'll show you here.
The private repository we can't clone, but the public one I meant to say.
Even a public repository you can clone. See, that's what I told you in the settings part. If you have access, if you have that access, you can clone that. But
Okay.
as I told you, if I want to clone something like a Kubernetes one, right? Kubernetes. Sorry. Where is that Kubernetes? Anything. This can be anything. Like it's not just this one. So even this one, I cannot clone it. I can only fork it. Okay. Even if I do a clone, when I want to get into their project, because it's more into a kind of okay. So when you say if it is a public repository, I can clone it, right? Is that what your point is?
Yeah, at least yes.
Yeah, that makes
Like at
sense.
least I
But
can download their code into my local and then maybe I can modify it and work on it. Some maybe I might not be able to upload back to their repository, but
yep. So that's the fork part. So if you're having access when you clone it, right? So you are part of their team. But if you cannot directly send it, then it is kind of a forking part.
Okay.
Yeah. So you don't have a point. See, here you have this fork, right? So you can actually fork it. See, you don't have any fork of it. I can create a fork. But cloning, yes, you can try cloning, but until otherwise we have access to it, we cannot do it. So that's the difference.
Okay.
Yeah. And thank you. Thanks for the question. And then the commands that we use every day. Yep. So let's get more practical. So some of the 6 commands I'll tell you here, which we will use very constantly, probably multiple times per day, I will say, if you are a regular user of Git. So starting with git init. So git init, again, when you're starting a new repository, so when you want to turn any folder on your computer into a Git repository, you open your terminal in that folder, and when you type git init, and that's it, the folder is now being tracked by Git. So without that, you're not part of the Git world. And then the next one is the Git clone. So you copy a repository to your computer, as I told you, Git clone, and then give the URL. So you're gonna clone your repository. So this will actually download the entire repository from your GitHub to your machine. So you'll use this when joining a new project or when you want to make some changes to a new project. And then the Git add. So this is where you're gonna stage your changes for commit. So after you edit your files, you use Git edit to store them, okay, or to stage them. So you can use, you can stage individual files like git add index.html, or you can use git add space dot to commit everything. So remember the same shopping cart analogy. So this is putting items on your cart, okay? Just you're putting items in your cart. You are not yet staged, you're just putting it in your cart, that's it. Or you're not committing it yet. The next one is committing. So this is where you're going to save your changes with the message. So you're using git commit -m and then the message. So this will save your staged changes as a commit. So the -m flag means you're going to include a commit message right in the command. If you're not using -m, you can directly, it will actually prompt you to add a message separately in a separate window. And the next one is the git push. So you're going to upload your changes to a remote repository. So once you have committed locally, the git push sends those commits to GitHub. So now they are backed up and they are visible to your team. Okay. And next, the git pull. So where you're going to download your changes from the remote repository. The git pull is the opposite of push. Yes. So it downloads any new commits from GitHub to your local repository. In fact, we'll see that in detail session. You'll get you'll use the use this git pull command to get your teammates work. And these 6 commands are your daily toolkit, starting from init or clone to start, adding to stage, and then committing to save, and then push to share, pull to receive the changes from others. Okay. In a full workshop, I'll cover about 30 more other commands and various flags and options. But honestly, you'll do 80% of your work with just these 6 commands. Yeah, I personally, I know these 6 commands are the very critical commands that you need to know. But don't worry about memorizing any syntax right now, because you'll develop your muscle memory the better. And if you make any mistakes also, the Git will actually tell you that is this the command that you want to try, and then from there you can copy paste and you can do it. So the important thing is just understand where or which command or what command you are going to use it conceptually and where you're going to use it. Okay. So quick check to make sure that you're following me. I think we have covered a lot in the last few 20 to 25 minutes. So this is the good moment to take a quick pass and check in. I want honest feedback. Don't worry. I'm not going to judge anything. So this will help me to know if I need to slow down or I need to clarify anything, or if we are good to continue. So just give a thumbs up if it makes sense so far. So if you're following along and the concept of clicking, so thank you. Thanks for thumbs up again. If you're a bit confused, please let me know. That's okay. That's fine. I can very well explain it to you. And if you need more clarification, please give a thumbs down. If you need more clarification, or if you're lost and if you need me to back up, thumbs down. I'm not going to judge you. So remember, questions are always welcome. I mean, very sincerely. So these are not, I'm not going to judge you. So if you're confused about something, someone else probably is too, but don't worry. Finally, we'll move on to the next one. So what we haven't covered yet, I'll tell you. So now we have learned the fundamentals. We talked about the repositories, the commits, the branches, the pull requests, the basic workflow, and that's awesome. So that's your foundation. But here's the thing, what we have covered today is really just the beginning, because it's like learning to drive into a parking lot. But the real world has a highway traffic and complex situations. So let me show you what we haven't covered yet here. So advanced branching strategies, the Git flow, the GitHub flow. Remember when we talked about branches, so in professional teams, there are entire methodologies about how to use branches, because Git flow, yes, they have branches for development, staging, releases, hot fixes. So it's a whole system. It's a very big system. And GitHub flow is a simpler but structured. So these strategies will prevent chaos when like 20 developers are working simultaneously. And the next thing is the merging of conflicts. So how to resolve them like a pro. So here's a guarantee. So eventually you and a teammate will edit the same line of code. And this has actually happened several times for me as well. So Git will say, I don't know which version to keep, and you decide. So that's the merge conflict. I'll explain you how to do that later. So that's very scary for the first time. Yes, it was very scary for me, but now I can just handle it in left hand. So, but with the right knowledge, you can easily manage the conflict as well. Initially, it'll look very critical. You do not know what exactly to do, but don't worry, it's easily approachable and handled. And then rebasing and rewriting history. So sometimes you want to change your commit history, you want to combine the commits, you want to reorder them, or you want to edit messages. So rebasing is an advanced technique that will make your history cleaner and more professional. And the next thing is Git hooks and automation magic. So hooks let you run automated checks before any commit or push. Imagine before every commit, your code automatically is getting checked for syntax errors. So before every push, your test automatically runs, and that's called Git hooks. And the next part is professional team workflows. Yes, so how does a company like Netflix or Spotify uses Git? So what's the workflow for deploying to production, and how do you coordinate releases across multiple teams? And these workflows are crucial, yes, I know, in a professional setting. So that's what we are learning all these. And then the best practices that separate the juniors from the seniors. So there are conventions, there are patterns, practices that experienced developers follow. So how often you commit. Initially, when I was there, I used to commit each and every change, and then I understood, okay, so there should be some point of time where you have to take a break and then you have to commit. Like you have to club all your changes and then you have to commit, not just for every commit. Because when you run a commit, right, what happens is it actually triggers a change. It actually triggers a workflow in your Git. So someone will in your team will be like, okay, come on, what is this guy doing, kind of thing. So always be very careful. You must know how often you should commit and how to write the PR descriptions. That's the pull request descriptions, and when to create branches, because these separate professional developers from the beginners. Okay. So all of this and more is covered in our comprehensive 4-hour workshop. So this pre-session will, which we're going through, will give you the foundation. So the full workshop will give you the professional level mastery. And then the next thing, which is the fun fact about the merge conflicts. Uh, Speaking of merge conflicts, since I mentioned them, so let me share some fun facts because they are part of every developer's life. So merge conflict happens when two people edit the same code, right? So it's very inevitable in team projects because you're working, you both are working, both committed to changes, and Git says, wait, there are incompatible, and please figure it out, okay? And then, in fact, Stack Overflows gets 15,000 plus questions about them yearly. I know because I used to go to Stack Overflow and check like how to fix this merge conflict issue. Yes, so Stack Overflow is the place where developers go when stuck. Yes, I do that. So merge conflicts consistently among the top Git questions, and you're definitely not alone if they confuse you. Developers have written songs and memes about them. Yes, so there are actually songs on YouTube about this as well, about merge conflicts. There are like countless memes as well. So the developer community has collectively experienced the pain, and in fact, they have turned into a humor again. Talking about the manageability. So they're totally manageable, yes, with the right skills. The truth is, merge conflicts seem terrifying at the moment because when you go, you make some changes and you find some messages in the pull request that your code has to be, there is some conflicts and please manage it or merge, manage the conflict before you merge it. So you'll be confused like what should I keep, what should I remove? So when you don't understand them, yes, it's quite terrifying. But once you learn the technique, and we'll, as I told you, we'll cover this extensively in the full workshop. So they become your routine. Okay, that's a merge conflict, and let me resolve this real quick. 5 minutes, and you're done. So in a full workshop, I'm going to teach you to handle them confidently. We don't just explain the merge conflicts theoretically. We'll create them intentionally in exercises, and you will get practiced resolving them with guidance. By the end of the workshop, you'll actually feel comfortable when you see one. The reality is merge conflicts are part of a collaboration. You cannot escape from that. It's part of a collaboration. It happens because you can avoid them by means of working alone, but mastering them will make you more confident when you work in the team. And that's what people expect, right? And honestly, once you know what you're doing, they are kind of satisfying to resolve. It's like solving a puzzle. And talking about some real world scenarios. So if you're working on a new feature branch for like 2 days, you have been heads down coding away and you have made maybe like 20 commits on your branch. So you're feeling good. The feature is almost done. Meanwhile, your team pushes 50 updates to main. Okay, so while you're working, your teammates were not idle. They have been pushing code, they are pushing bug fixes, features, updates. So the main branch has moved forward significantly, and your branch is now way behind, right? So you finally look up and realize, okay, your branch was created 2 days ago, but main has changed dramatically since then. Okay, your branch is based on outdated code. So you have taken a let me explain it. So you have taken a code from a main branch today, or like 1 week back, and in this 1 week your team will keep on updating changes, and they'll merge everything to main. So by the time your code is a old outdated code, right? So the same thing happens here. So how will you integrate the changes safely? And that's what we're going to see. So that's the question. So you need to bring those 50 updates from the main into your branch, but you also have your 20 commits, right? So how do you combine them without breaking everything? And that's what I'm here for you. So how do you avoid breaking everything? And the scary part here is, if you do this wrong, you could break your feature, okay? Or you could even break your main, or you could create a mess that will take hours to untangle, okay? So these real situations need skills beyond basics. The commands that we learned today don't uncover the scenario, because you need to understand the concepts like merging, rebasing, conflict resolution, testing strategies, and safe integration practices, because these scenarios will happen constantly in a professional development. It's not theoretical. In fact, it happens every day when multiple people are working at the same time. So as I told you, in the full workshop, we'll practice exactly this scenario. You will learn multiple strategies for handling it, understand the trade-offs of each approach, and I'll help you to practice until you're confident. So this is what I mean by going beyond the basics. The real world software development has complexity that requires the advanced skills. Okay. So now a quick poll. I just want to hear from you. Based on what we have discussed, both what we covered and what we have not. So what are you most interested in learning? So this actually helps me, because if there is strong interest in particular topics, I can make sure we emphasize those in the full workshop. So I'll just reveal all the options. Yep. So branching strategies and workflows. So how teams organize their work and coordinate using branches, handling merges conflicts confidently, not being scared when conflicts appear, and talking about the team collaboration. So how to work effectively with other developers, and talking about automation with Git hooks. Yes, making Git do things automatically to save time and prevent errors. And everything sounds interesting. So I just want to collect your feedback in this part.
I would choose all the
All the
above.
above.
Okay, thank you. I'll note it down, and then move to the next one. Okay, the full 4-hour workshop that we have planned. So let me tell you about the comprehensive workshop that will take you from where we are now to professional level Git proficiency. The first thing is advanced branching, Git flow, GitHub flow, and trunk base. So I'm going to dedicate a full hour to branching strategies. So you'll learn Git flow, the methodology used by many large companies with structured release cycles, the GitHub flow, which is a simpler, faster, but it's used by startup and agile teams. And then the trunk-based development, it's not just GitHub, it has like several branching techniques, right? So that's the reason I'm telling you about this. So the cutting edge approach, it is used by companies like Google and Facebook, and you'll understand when to use each strategy and why. And then the next part is just mastering the merge conflict resolution. So we create merge conflicts intentionally, and you resolve them with real-time guidance. So you will learn to use merge tools, you will understand conflict makers, and you will develop a systematic approach to resolution. So by the end, conflicts will not scare you. And then the next part, which is rebasing, cherry picking, and history magic. Yes, so rebasing is a powerful, but if it will be dangerous if it is misused. So I teach you when to rebase and when not to, and how to do it safely. And because cherry picking lets you select specific commits from one branch and apply that changes to another, which is very incredibly useful. In fact, I actually told you, I'll explain it to you again. So I'll cover interactive rebasing to clean up your commit history, and then the team collaborative workflows which are used at top companies. So how does a company coordinate 100 developers who are working on the same code base. Yes, and how do you handle the rebases and how do you manage hard fixes? So we'll study some real workflows from companies like Google, Microsoft, and successful startups as well. And you'll understand the principles behind these workflows so you can adapt them to any team. And talking about the Git hooks and CI/CD integrations and automations, this is where the Git becomes truly powerful. Yes, so we're going to set up the pre-commit hooks that will check your code formatting automatically, and you can pre-push your hooks that will run your tests, and you will integrate Git with CI/CD pipelines. So when you push your code, it automatically builds, it will test, and then it can even deploy. And this is how the modern DevOps works. And talking about the real world exercises with guided practices, yes, this is not just a lecture only. You'll work through scenarios on your own computer with my guidance. You'll create branches, simulate team collaboration. You can intentionally create and you can resolve conflicts, and you're going to practice rebasing, and you're going to learn by doing how this skills really stick with you. So the workshop is actually 4 hours. It's going to be very intensive, but it's very structured with breaks and pace. So you're going to observe everything. So you will leave with not just just knowledge, but actual muscle memory and confidence. So what you'll gain? The confidence to handle any Git scenario. Is that feeling of panic when something goes wrong with Git. It's going to be gone for your lifetime. So you'll have seen enough scenarios and you'll practice enough solutions that you will approach Git problems calmly and systematically. And you will get to know, okay, this is what happened and I know how to fix it. Okay, so that's the level of confidence you'll build at the end of this session. And the skills that employee actively seek. Yes, I'm talking about very serious scenarios. So look at any developer's job posting nowadays, any posting. They almost all mention Git, right? If I'm not wrong, and the version control or collaboration workflows. But here is what they don't say or they don't tell you. They expect you to know the advanced stuff. They'll say Git, but they want you to know the advanced stuff. So they assume you can handle merge conflict. You must understand branching strategies and work in a professional workflows. This workshop will actually give you exactly those skills that the employers expect, but they don't have time to teach. Yes, they don't. They have a lot of time. If you ask some questions, right, they'll like immediately shout like anything. If you ask some basic things, yeah, that happened to me. That's the reason I just want to get you people to avoid those scenarios. And then the ability to collaborate in any dev team. Yes, so whether you join a startup, a large corporation, or if you want to contribute to open source, you will understand the collaboration patterns. So you won't be the person who is slowing down the team because you don't know how to properly use Git, but instead you'll be collaborating effectively from day one. And that's what I wanted to happen for all of you from day one for after you complete this course. Understanding of industry standard workflow. So you'll speak the language. When someone says we use Git flow or we do trunk based development, you will immediately know what that means and how to work within that system and even be able to adjust improvements. And talking about the practical experiences through fun exercises, yes, this is not just theory. You will get that you forget next week. We'll do hands-on exercises that simulate real situations. So you'll make mistakes in a safe environment in our place. That's not a big deal. You can learn from them and you can build genuine experience. So the exercises are designed to be very engaging and it's going to be more fun. And then talking about the workshop investment, the duration is going to be like 4 hours of intensive hands-on training. So I'll typically run this either as a 4 full hour session with breaks or split across 2 2 hour sessions, depending on your feedback. So both formats will work great. It's really about what fits your schedule better. So the split formats gives you time to practice between the scenarios as well. You can come up with the queries before we start the next session. And talking about the format, it's going to be very interactive with practical exercises. So this is not me talking at you like all the 4 hours like I did now. So we are going to balance the instructions with hands-on practice. You'll have your computer open. You'll follow along with me doing your exercises, and I'm here to guide and answer your questions in real time. So you'll learn them by doing, not just watching. And the materials is going to be complete reference guide, and there will be cheat sheets as well. So you get a comprehensive PDF guide that covers everything that we discuss with commands, examples, diagrams. Plus, I'll give you a cheat sheet which you can keep by your computer for your quick reference. So these materials will alone are worth the price of admission. And then the support, the QA sessions plus post workshop resources. Yes, during the workshop, you can ask unlimited questions. After the workshop, you get specific support from me. And as I told you, I mean, even now, people are like, I'm reachable on WhatsApp all the time. So you're not abandoned after the workshop ends. So don't worry about that. So there are like limited seats for personalized attention. I'm not intentionally, I'm planning to have like between 10 to 12 people maximum. So this will ensure I can give individual attention to each and every one of you. So you can see a screen, and if you're stuck, and you can make sure that everyone succeeds. It's not a massive lecture hall like 100 or 50 to 100 people. So yeah, that's it from me. And if you have any questions, you can ask me very well. And I believe whatever I have taken so far in terms of GitHub will actually give you a foundation knowledge on what we're going to discuss in the comprehensive session. So any doubts, any questions, please feel free to ask. Thank you.
Thanks, Susan. Thanks for the session.
Thank you. Thanks, Mahendra. Thank you so much.
Hey, so when is the workshop going to?
Yeah, once I collect, once I have the enough number of participants, we'll start it, Manu. I'll keep you posted. Anyways, you're in touch, so I'll keep you posted on that, Manu.
Okay, sure. Thank you.
Yeah, thank you. Thanks, Manu.
Yeah.
Thanks so much.
Yeah,
Thanks,
thank
Mahendra.
you.
Thanks for joining. Yeah, see you all very soon. Take care. Bye-bye.
Bye.
Bye.
Thanks, bye.